Rain1290 with you to bring you the next thunderstorm risk analysis. In this case, we do actually have a severe thunderstorm threat that could be transpiring for August 13th, Wednesday, August 13th, 2025. So it goes without saying that we haven't been seeing that many thunderstorms. For those of you who are observing thunderstorms, you're probably noticing that we've been actually struggling to actually see thunderstorms for the last little while. So really, if you live on the island of Montreal, it hasn't been since August 2nd, especially if you live in the eastern part of the island. August 2nd was your last thunderstorm day, but in general, the last severe thunderstorm day, including for western parts of the island, and thunderstorms in general, was July 17th. So yes, it has been nearly a month where the west end of the island of Montreal has actually seen a thunderstorm. If you live on the eastern side or in Greater Montreal, the last thunderstorm day was August 2nd, so you're more recent. So stick with me to the end of the video. I will be also answering your questions. Stick them into the comment section below. I promptly answer. I will comprehensively answer them as well. Any questions, curiosities, anything out of curiosity going forward as well, just leave them in the comments and we'll take it from there. So let's just go towards August 13th very quickly. Right now we're still on August 12th. Let's go to August 13th and look for those brighter colors, which is representative of higher surface convergence, because that's what this map is showing us, surface moisture convergence. Really what we're seeing by the end of the morning of August 13th, so it's 11 o'clock, Eastern Ontario, Western New York, Central New York, and north of the island of Montreal, we're already seeing these brighter colors starting to take place out of that cold front. And then going into the early mid-afternoon, you're starting to see this huge area of higher lift or surface convergence that's actually appearing ahead of that cold front, represented by these red to even purple colors. So we are seeing stronger lift taking place here. Okay, so now turning our attention to the 500 millibar altitude. So this is a measure of vertical velocity measured in microbars per second. So just like surface convergence, we're looking for the brighter colors. So we do actually have a shortwave trough as represented by this line of brighter colors from darker greens all the way up to even purples in some areas. So we do have a fairly strong shortwave trough that is taking place, and it is joining forces with the cold front. So this is for the morning of August 13th, so 8 a.m. This is how it looks in western Quebec and eastern Ontario and portions of New York. And then we go forward and you start to see greater amounts of lift occupying a larger space by later in the morning. And then as we go further again, this crosses pretty much southern Quebec and upstate New York during the mid-afternoon of August 13th. So really what we're seeing here for August 13th, so this is pre-dawn or just around sunrise of August 13th. So really what we're seeing is already a high amount of instability, which is what we would expect in a situation like this where we're still captured in this extensive heat wave, one of the longer heat waves that we've seen in recent years, but it does come with a lot of energy, of course. So during the morning, we're already at 1500, even 1750 joules per kilogram for Cape. But as we go farther into the morning and then going to the afternoon, so this is like later morning, and we're seeing these greens starting to appear in much of the Northeast and Southern Ontario to southern Quebec, and we're seeing values close to 2500 joules per kilogram, and then that goes right to the end of the afternoon. So this is mid-afternoon, then late afternoon, that's still holding together in eastern Ontario, southern Quebec, around the island of Montreal. So still large amounts of instability are present, and that means it's very likely that thunderstorms will stay with us in the area right up to around sunset and even potentially a little bit beyond. It depends on the newer data that comes in. Okay, so despite how much instability is taking place, we're not getting a huge contribution from our mid-level lapse rate, so we're not seeing all that much cooling taking place at the mid-altitudes of the troposphere, so this is not really giving us all that much contribution to the amount of instability. So despite the lack of stronger mid-level lapse rates, this tells us that the low-level lapse rates and the humidification rate are largely responsible for the instability that we just saw. So let's take a look at those. As we would expect, as we go deeper into the morning, yes, you are actually seeing these brighter colors start to overspread much of the Northeast and especially upstate New York into southern Quebec, including around the island of Montreal. It's around 11 o'clock in the morning on August 13th. So this is doing exactly what we would expect in order to drive up the instability to 2500 joules per kilogram for Cape. And this pretty much stays with us right into the afternoon. What this actually shows us is that the cloud cover is not too intrusive. It is allowing the sun to get through between rainfalls and cloudy periods as well. So we are actually seeing sufficiently steep rates going to the afternoon, right through the afternoon actually. So this area is staying quite unstable because of those breaks. Okay, so just doing a quick check on our dew point, so how much humidity is actually present in the air. So you probably noticed this month and really during this heat wave that we haven't been seeing particularly high humidity. It's been high, no question, but we haven't seen particularly high, like very high humidity so far this heat wave in this month. So let's actually take a look at our last day of this heat wave. For most areas, it is actually a heat wave. So let's see how the moisture looks for this last day. So right now we're in August 13th, pre-dawn. Now we're actually going into later morning, and you actually see this area of purple, different shades of purple, representing the highest humidity in this case, reaching much of the Northeast and Eastern Ontario, Southern Quebec, and that represents dew points in the lower 70s Fahrenheit. That's the equivalent of about 21 Celsius or greater, 21 to 23 Celsius. So that represents very high humidity, easily the highest humidity we've seen so far this month, and really during this heat wave. Okay, so quickly, just selecting a sounding profile. This is from the west end of Montreal at 11 o'clock in the morning of August 13th. Quickly looking at the wind shear profiles represented by these wind barbs, we're seeing mostly a unidirectional shearing field. So a modest speed shear profile taking place in the form of southwesterlies. So it's mostly unidirectional. We do have a slight veering component near the surface in the form of south-southwesterlies, but then that becomes quickly a southwest flow throughout much of the troposphere. So it's not really that much organization taking place, but arguably, it is still enough to support some organized thunderstorm families that do initially form ahead of our lifting features. Now, the next thing to look at is the instability factor. As we saw before, we do have a K value of about 2,500 joules per kilogram. I wouldn't rule out even closer to 3,000 joules. That's what this is suggesting. About 3,074, 3,100-ish joules per kilogram. So that's what's occupying the space here between this red curve, which is the environmental temperature, and how that's changing with increasing altitude, relative to the parcel temperature curve, which is this dashed blue line, and how that's changing with increasing altitude similarly. Our green curve shows us how moisture, or dew point, is changing with increasing altitude. And that's actually a good point because at the mid-altitude, so around 500 millibars, we're seeing how quickly the dew point temperature is decreasing with increasing altitude. So we have a bit of a hydrolapse taking place later in the morning. So that represents a rapid decline in moisture. So there is a rapid drying effect taking place here. Meanwhile, we have a very humid surface. So again, we have a dew point in the lower 70s. That's very high humidity. And as I showed before as well, mid-level lapse rates aren't terribly steep. However, we do see a fairly cold 500 millibar temperature, about, let's say about -8. So this is 500 millibars. If you follow this red curve diagonally down, parallel to these diagonal lines, you will end up with a temperature of about -8 Celsius. So it's still, despite the absence of steeper mid-level lapse rates, we are seeing fairly cold mid-level temperatures, and that's still supportive of potentially aggressive lightning frequency with some of these thunderstorm families that do actually take place. And it is also supportive of a small hail hazard. So that will also be something to watch. Now let's just skip ahead one time step. So this is a sounding profile for 2 p.m. now, same area, west end of Montreal. So we're seeing pretty much an identical profile is taking place. Not too much improvement with our shearing profiles. In fact, it looks a bit more disorganized in our boundary layer. But nevertheless, it is a little bit more supportive of organized thunderstorms. We do have a more saturated profile as well by mid-afternoon, so nothing too impressive for drawing, but we did have that drawing profile shown in the previous time step, so that is still significant. So if I go one step forward to capture the mid-afternoon to late afternoon, so this is now 5 p.m., same area, we do see that drying effect taking place again, still large amounts of instability, still very high humidity at the surface, and a somewhat improved shearing profile, and somewhat colder 500 millibar temperatures. So that will improve or keep the chance alive for thunderstorms with high lightning frequency and a small hail hazard. So this will be something to watch. Thunderstorms won't be terribly fast moving as well, as we saw with this wind shear profile. So we're not seeing particularly strong wind fields at the mid-altitudes, but it is enough to support somewhat fast-moving thunderstorms. So these thunderstorms will also invite some opportunity for flash flooding, especially because of our high humidity factor. Of course, we also have a strong drying effect, so again, this will also invite a strong wind hazard locally. Okay, so based on the environment and where the lift is most aggressive along that shortwave trough and surface cold front, I expect thunderstorms to be forming in this broad red zone. So within this red zone doesn't mean everywhere within this red zone is going to be seeing thunderstorms, but I do expect thunderstorm coverage to adopt a fairly scattered to mostly widespread. I think I'll go for widespread in this situation where we have many thunderstorms developing and all of them moving off mostly to the northeast, so in this kind of fashion. Now, as I showed with the sounding profile, the wind fields, our wind shear profiles are not particularly aggressive, and the 500 millibar flow or the mid-level flow is not super strong. So the thunderstorms themselves are not going to be moving all that quickly. The environment, however, does resemble what we saw on July 13th. And I just want to stress it doesn't mean we're going to see exactly the same sort of outcome as we saw a month ago. And eerily enough, this is happening on August 13th. But the environment is quite identical to what we saw on July 13th in terms of the instability factor, the shearing fields, etc., the thunderstorm movement, and still it does improve the chance to see at least something similar in some areas. So this is something that we need to watch. Now, the dominant hazards will be mostly very heavy rainfall, so I do expect a localized flash flooding hazard. Lightning frequency, I think, will be high with some of these thunderstorms, especially later in the morning and especially going to the afternoon. And on that note, I do expect thunderstorms to be mostly occurring during the late morning all the way up to about sunset. Now, the greatest lift, as I showed previously, is mostly happening along that cold front as well as the accompanying shortwave trough, right? And then both of these are moving off in this direction as well. So the lift associated with these features will stay with us, especially the shortwave trough, will stay with us right up until sunset. So these thunderstorms will be largely developing up until that point. Now, going back to the hazards, I also expect, as I mentioned previously, a small hail risk with some of these thunderstorms as well. And there is a chance for locally damaging winds, not particularly widespread damaging winds, but locally based, because as I showed before, we have that drying that's taking place at mid altitudes around the 500 millibar flow, and that will be supportive for localized strong downbursts. So that is something else that we need to watch. So that is pretty much the situation for tomorrow. And as a bonus, I do see a localized area of lift. So ultimately this evening for August 12th, I mean, it's not a serious risk, but there is a chance for isolated thunderstorms just northwest and a bit north of the Island of Montreal. So it could capture this general area just barely at the northern fringe. So there is a subtle zone of lift, a subtle shortwave trough that I think may take advantage, or thunderstorms could take advantage of that feature late this evening into possibly early pre-dawn. So we'll have to watch the zone as well for later today, August 12th. Pretty much that's where we stand between later August 12th and especially August 13th. So that's your risk analysis. If you found this video useful to you, if you found it very insightful, please feel free to subscribe to not miss out on upcoming forecast videos. I focus, as you might have guessed already, mostly on the Northeast and with a focus on the Island of Montreal especially. But I will also do other areas if you so desire. So ultimately, that's where we stand. I'll leave you with these playlists. If it's of interest to you, you can look at previous documentations of thunderstorms that I've taken from this section of the Island of Montreal here. And I'll see you in the next video. So we'll also look out for any new updates because there is still time to evaluate this situation. And any new sizable updates I will mention in the comments below. Meanwhile, as I said at the beginning of the video, leave your comments below and I will address them promptly and comprehensively. So do not hesitate to ask anything that you found maybe unclear in the video or you would like more information. And if you would like any updates, just let me know. Otherwise, I will see you in the next video. So once again, thank you for your attention. Really appreciate it. If you made it this far, thank you, thank you, thank you. Cheers.